let's see. Do we want to just go starting with 4-106? You know what?
Yeah.
I just realized I can download it. Let me do that.
Okay.
Makes it a little easier if I can download it, because then I can blow it up, rotate it if I need to. And take a screenshot. Use one of the strategies of looking inside, rewriting, or undoing. Well, I don't know what any of those mean. I can
I
probably figure it out though.
yeah. It's basically like what it's like asked for is like for this for A is like dividing by two as opposed to like
Yeah,
solving a
let's just find one way to solve A. Go ahead and give me the next line, and you can pick any way you want.
I was just gonna divide everything by two so that
Well, is that really the best first step? In other words, when you're looking at an equation and you're trying to solve it, really the best thing to do is to get rid of anything that's being added or subtracted first. That plus 8 is being added.
so subtract eight from both sides.
That's what I would do, only because then you don't have to worry about dividing that 8 by 2. Um, Now, what's the next step?
Would you square root both sides?
Well, this 2 over here is not being squared. That is not inside the
Yeah.
parentheses.
Then
So we got
would
to get rid of that 2 before we do that.
so just divide everything by two.
Yeah. In other words, the whole goal is to isolate y. And you do it one step at a time. Now, the next step.
Square both of the like things in the parentheses, the y and the negative one.
Square root both sides of the equation.
Oh, right. And then,
In other words,
why am I?
remember the most important thing in algebra is you can do anything you want to one side of an equation as long as you do it to the other side. And that
Yeah.
means virtually anything. I mean, you'd be amazed. Once you get to higher math, you can take derivatives, integrals, logarithms, anything you want to do. Well, in this case, we want to take the square root. So tell me the next line.
Y minus 1 is equal to 6.
Everybody goes wrong here. Whenever you are solving an equation by taking the square root of both sides, always, always, always start your answer with the words plus and minus.
Oh,
If I told you that y squared was equal to 4, then y is plus or minus 2. And notice why it is. In other words, minus 2 works. If you square minus 2, you get 4. You get positive 4. So when I say y squared is equal to something and I take the square root of both sides, it's always got to start with plus or minus. Key thing. I would say one of the top 3 errors in algebra that is made is that right there. What's the next step?
add 1 to both sides.
Okay.
Go y by itself.
So now I've got this. And now tell me the 2 answers.
So then it'd be 7 or 5.
What's 1 minus 6?
Oh, -5. 7 and -5.
Those are your two answers. Now, the question is was that looking inside, rewriting, or undoing?
Undoing.
I would say undoing because we took the square root of both sides.
Yeah.
All right, let's see if we can figure out how to rewrite it. I think I know what they mean. If I was going to rewrite that, what would be my first step? I don't care what they call it. My first step is always to get rid of that 8. Okay,
Yeah.
we'll still be able to do it rewriting it, but let's at least keep our numbers reasonable. In other words, you're always better off with fewer and smaller numbers. And in fact, let's divide both sides by 2. That has to be the correct next step. Now, rewrite it. In other words, at this point, we have an option. We can take the square root of both sides, which is undoing it, or we could rewrite it. In other words, expand that is what I suspect they mean.
So y minus 1 and times y minus 1.
Okay, which is?
Here, let me FOIL it.
That's exactly what you have to do.
Then it's y squared minus y minus, okay, so y squared minus 2y minus or plus 1
equals 36. Now what? Now we have something that looks more like a standard quadratic. When you have a standard quadratic, it means you have a squared term, a non-squared term, and a number.
Yeah.
How do I solve this?
You get you to just subtract the 1 first to get y by itself.
Nope. That's the third method. That's the looking inside method, I'll bet. But let's do this the normal way. The rewriting of it means put it in standard quadratic format with 0 on the other side. In other words, subtract 36 from both sides. That's usually what you're trying to do when you're going to try to solve a quadratic. Is you get everything on one side, you get 0 on the other side, then you factor the quadratic. Well, how's that quadratic factor?
So then it's y's, and then it's plus and minus, and then 35 factors. Okay. So then 5 and 7. So then 7 goes with the negative.
Good. Notice we got the same two answers. Y equals 7. See how I got that? And y equal minus 5.
Yeah.
Okay, that was the rewriting method, I guess. I don't know his terminology. But there is one other way I can think of doing this. And I actually like this a lot. I have not seen very many people take this approach. This is the Asian approach of teaching mathematics. I've read that the difference between Asia and the United States is that in the United States we give a student 20 problems in an hour, and in Asia they give 5 problems but looking at it from 4 different ways. Well, this is 4 problems looking at it from 3 different ways. Okay, let's complete the square. Let me do this first of all. Let me get it to this point. because I'm never using any method that doesn't do this as your first two steps, which is to subtract 8 and divide by 2. However, at this point, you can expand it, which we did. I can only think of a third way at all. Move the 1 over. I'm just going to run through this with you and hope that this is what your teacher is talking about. In other words, if I were to be given this and said solve it, I would have a couple of choices. I could bring the 35 over, factor it, do it that way, or I could complete the square, which is to add a term inside the parentheses and then add the same term on the other side, and then be able to write this as a linear term squared. So how would I complete the square here? What's the process of completing the square?
I could not tell you.
Take half, look at the coefficient of the x term. Excuse me, that's a y term. The coefficient of the y term, take half of it and square it. What do you get?
1.
Plus 1. Now I've got to add plus 1 over here to keep everything balanced. And then I can rewrite that as y minus 1 quantity squared equals 36. Then I can take the square root of both sides. Y minus 1 equals plus or minus 6. And then I can figure out that y equals 7 or y equal minus 5. Now, this might look like the same solution as what we did originally, but it really isn't. There are 3 very different methods of solving this problem. And we basically did all 3 of them. I'm not sure that I got the terminology correct, but it doesn't matter. These terms are not mathematically significant. Nowhere else when you get to math will you be seeing those terms. Other than this teacher has used these terms to mean these techniques. Now, when's your test, Blake?
It's tomorrow.
Okay. So we have a limited amount of time. And the question is, do we want to do B through D, or do we want to do at least one from the next one? I'm thinking we should do one of those, and then maybe that one, and then go back and do that one, and then do that one in that order. Okay?
Okay.
So let's do this one here next. Solve each system of equations without graphing. For each case, explain what the solution tells you about the graph. Well, I can only assume that the system of equations he means is A and B. Am I correct? Yeah,
I think so.
In other words, a system of equations could include all 6 of them. And he's put a space between B and C, but I don't know what he means for the rest of it. I'm assuming he's grouping these like this. You got that system, you got that system, and you got that system.
Yeah.
All right. We'll assume that's what he means. Let's solve the first system without graphing. So solve it algebraically.
So since they're both equal to y, couldn't you just set them equal to each other?
Good.
Here, I'm going to flip to the page. Okay.
Now what?
And then,
Now the
well,
moment you see that, what are we looking at? How are we going to solve it?
get all the x terms on one side.
Get everything on one side. We see an x squared term, we see an x term, and we see a number. When you see all three of those, then you got to get it into ax squared plus bx plus c equals 0. That's always the way to solve it, and then factor it. So, how do we do that? What's the next line?
So then it would be 1/3 x squared minus 2x, and then plus 3 is equal to 0.
Okay. Now, we are not used to factoring when we have fractions in front of the x squared term, correct?
Yeah.
So what can I do to get rid of that 1/3?
Multiply everything by 3.
Okay, tell me the next line.
Then it's just x squared minus 6x plus 9 is equal to 0.
Not plus 9. Excuse me, my apologies. It is plus 9. What was I thinking? Been a long couple weeks.
Yeah.
I'm looking forward to Christmas break, actually. Now factor that.
So then it's x, and then it's minus and minus, and then it's 3 and 3 is equal to 0.
So what's x equal to?
3.
And that is the only solution, which is a little unusual because usually quadratics have two solutions. This is actually called one solution with multiplicity of 2. Have you learned about multiplicity yet?
No.
Okay. It's interesting because when you have an even, you can see why it's a multiplicity of 2, right?
Yeah.
Okay. For each case, explain what the solution tells you about the graph of the system. Well, an even multiplicity is a very interesting result. What it means is that your parabola doesn't go through the x-axis at that point. In other words, I know that this is a quadratic, so it's a parabola, and it opens up, and its solution, its 0, comes at 3. But what the multiplicity tells me is that since there's only one, it kisses off the x-axis. It doesn't cross it.
Mm-hmm.
If I had two different zeros, then the vertex would not be on the x-axis. It would be below it, and I would have two x-intercepts. So I guess that's what he's looking for in explain what the solution tells you about the graph. The fact that we only got one solution, x equal 3. And I still do need to figure out what y is when x equal 3.
So then it's 6 minus 2. So 4.
Yeah, hold on a second. I've done something wrong here. I'm not quite sure what. Let's see. X minus 2x plus 3. That's x minus 3 times x minus 3. X equal 3 is the 0, but when x equals 3, that's 4, and that's 4. So when x equal 3, y equals 4. So here's actually what they wanted. I apologize. In other words, whenever you have a system of equations, you always have to solve for both x and y. We weren't really solving for the zeros of this parabola. I don't know what I was thinking. We were solving for the x and y. And as all that says is that when x is 3, y is 4. Right?
Yeah.
Okay. Now, what that says about the graph
is that they intersect at 3, 4.
Yeah, I don't know what else you can say. In other words, from that solution, we don't know much about what the graph looks like. You and I figured out that it was a parabola that had zeros at 3. But something's wrong there. I'm not sure what I'm thinking when I do that. I think the only thing you can really say is that when x is 3, y is 4.
Yeah.
All right. All right, let's go back and do a second one from this one.
Okay.
Since I don't know the meanings of his words, let's just do it however many different ways we can think of doing it.
Yeah.
What's the most logical way to do it?
Just square both sides, square the square root.
Okay, what's the next line?
So 1 minus 2x is equal to 100.
Okay, next line.
Subtract the 1 from both sides. So then that's negative 2x is equal to 99. And then x is equal to, that's a decimal. It's like,
Don't put it as a decimal. Leave it as a fraction. Leave it as an improper fraction.
negative 99 halves.
That's the best answer. Believe it or not, it is. That's always a ratio is much better. And once you get into trig, you'll kind of understand trig and calculus why ratios are better than decimals. And that works. If I plug it in, I get 1 minus a minus negative 99, which is 1 plus 99 is 100. Square root of 100 is 10. So that's one way of doing it. I can't even imagine another way. I'm trying to think if there's a second possible way of how I would do this problem. Let me think for a moment before I erase anything. Can you think of any other way?
Not really. Because, yeah, you can't square root a variable.
Well, you could square root both sides, but that really makes it more complicated. In other words, that's not going to help. You can actually square root a radical. And sometimes you'll see answers like this. 1 plus square root of 2. That's a possible mathematical answer for some advanced problems. But it doesn't seem like it applies here. You can't imagine why we would do that. What else could we do?
I think that the way we did was definitely the best way.
I do too. I'm just trying to, he very specifically came up with 3 different methods for doing A through D. And I can't even think of a second one, let alone a third one.
Yeah.
At least on A, I was able to think of all three different methods. Whether they're the ones he's talking about or not, I don't know. But
I think that we just had to choose one of them to do.
You're right. Use one of the strategies. Okay. So, in other words, it's unimportant that we do it 3 different ways, or even that we know the name of the strategy. Okay, let's look at this one here. First thing we're going to do, we're going to solve it without graphing, so we're going to do it algebraically. What am I going
to set them equal to each other?
Now what?
Square both sides.
What's the right side?
X squared plus 25.
Biggest mistake made in algebra is the one you just made.
Oh, plus or minus. Oh, yeah, because you have to foil it.
You got to foil them together. Or better yet, let's talk about this because this is so important. I can't believe I have a lot of students that don't know how to do this. It's really worth memorizing this only because you have to do it so often. You have to take a binomial term and square it. And if nothing else, this will prevent you from making the mistake you made. Because notice that there's always a middle term. Whether it's a plus b or a minus b, there is always a middle term. In our case, it's that is our middle term. In other words, that is minus 2ab, a being x, b being 5.
Yeah.
If you memorize these two up here, you'll save tens of hours worth of unnecessarily foiling. You don't have to foil these every time if you memorize these formulas. So all you have to do is know that it's going to be x squared minus 2 times 5 times x. That's minus 10x. Plus b squared, b is 5, so that's plus 25. Okay, what's the next step?
Then it would be to get all the terms on one side.
Yeah. So what does that give me?
Okay.
And not more importantly, but just as importantly, is when you get all terms on one side, you want the coefficient of the x squared term to be 1. Or to be positive, not negative. So I don't want to bring the terms on the right all the way over to the left. I want to take the terms on the left, move them to the right. That will keep that coefficient positive. I'm planning on factoring. What else?
So 0 is equal to x squared minus 11x. And then plus plus 22.
Be more precise. Don't make little mistakes like that. You know how to do the problem. That would cost you big time.
When you add 28. Oh boy.
You understand what I'm saying?
Yeah.
The saddest thing in math is when a student knows how to do the problem and he makes an error in arithmetic and causes you to get the problem wrong. It's one thing if you don't know how to do it, but I know you know how to do this one. Don't make little math errors like that.
Yeah.
Even if you have to use your calculator. Although the calculator is not going to help. Because the calculator, you'd subtract 3 from both sides. In other words, it's not adding 3 or subtracting 3. You don't need a calculator. You just need to know whether it is adding 3 or subtracting 3? What is it? Once you know that, you'll get the right answer. Okay, now factor that.
So it's x and x, and then it's minus minus, and then it's factors of 28 that add to 11 is, okay, so cut in half is 14 and 2 now, and then third you can't do, so then fourth is...
Always keep trying to cut it in half if you can.
Oh, 7 and 4. Yeah.
In other words, the first time you cut it in half, you got that. Well, try to cut it in half again.
Yeah.
And that actually gives you all of them. You don't even need to investigate the rest of it. Once you get that down to a prime number, you're done.
Mm-hmm.
So 7 and 4. So the answer is x equals 7 or x equal 4. Now, since there's 2 x's, there's got to be 2 y's.
Yeah.
So what's y when x equals 7?
So y is equal to 7 minus 5, so it's 2 for 7. So it's 7 and 2 is 1, or 2 and 7, or...
Good.
Whew. Yeah.
And when x is equal to 4.
And then 4 minus -1.
How about when x is equal to 4 right there?
4 minus 3 is 1 squared. Oh. Plus or minus, wait.
Yeah, we have a problem. We have a problem.
Yeah.
Now, the question is, x equals 7 is a valid solution. In other words, this is a valid solution that satisfies both equations. When x is equal to 7, the top one is 2, the bottom one is 2. So x equals 7, y equal 2 is valid. X equal 4 is not valid at all. Notice that when I plug in 4, I get a y here of 1, and I get a y here of minus 1. Since they're not the same, then x can't be equal to 4. And you only have one solution.
Oh yeah, we learned about these. There's a vocab word.
They're called extraneous solutions.
Yeah, extraneous solutions.
And here's the thing. There's a reason for it. If I say AB equals 0, the laws of math tell me that either A or B or both can be equal to 0. One of them has to be. So I solve that by setting A equal to 0 and B equal to 0. But sometimes you come across things where both of them don't have to be 0, only one of them does. And the other one really doesn't. So in my case, I came up with 2 solutions. One was x equals 7. The other was x equal 4. But that was extraneous because it does not work. It does not satisfy that system of equations. So there's only one solution, x equals 7, which is perfectly fine. Remember what I had. I had x minus 7 times x minus 4 had to be equal to 0. Well, the only thing that means is that either that or that have to be 0. Well, I determined that that was the one that had to be 0. And it's okay if that doesn't have to be 0. So in terms of explaining what the solution tells you about the graph, I guess it's that there's only one intersection point. There's only one solution. It's x equals 7, y equal 2. And here, let's just graph it just so I can kind of illustrate what I'm talking about. The top one is the square root function, slipped 3 to the right, slipped 3 to the right, like that. The bottom one is straight linear equation going through -5 with a slope of 1. It must do that. Otherwise, you would have two solutions. Notice that if it did this,
then
you
you'd
would
have
have a
two.
solution there, and you would also have a solution there. So the fact that and if it did this, you'd have no solution. In other words, you've got to have an intersection between the two curves to have a solution. And the fact that we only came up with one solution tells us that the one curve, this one, has to be tangent to that one, which is our red straight line and our red curved line. They intersect at only one spot, and that spot is when x is equal to 7 and y is equal to 2. And I think he's probably looking for that as an answer, is that it is tangent. They touch at only one spot, not two spots. And that, when you're dealing with a curved line, means that the straight line is tangent to the curved line. Whenever a straight line touches a curved line at only one spot, it is said to be tangent to that line. That's what calculus is all about. What year are you, Blake?
I'm a sophomore.
Oh, so you're definitely taking calculus.
Yeah.
At some point.
Yeah.
All right, let's go up and look at this one here. Again, I'm just going to suggest we solve it in the simplest way, and then if there's other ways we can solve it, we'll look at them. Although, like you said, he's only looking for one. What's the best first step?
Multiply by y. Or just add 2 to both sides.
Yeah, notice why that's a better step. If I multiply both sides by y, then I got to multiply that 2 by y.
Yeah.
Whereas if I add 2 to begin with, then I eliminate one of these numbers. In other words, if I add 2 to begin with, I simplify the equation quite a bit. I get that. That's much simpler than it is to start with. And had I multiplied both sides by y, I would get this. But then I would have minus 2y equals 3y. I would have that. To me, that is more complicated. We'll get to that, but I truly believe that you're better off getting rid of stuff that, especially if it's just numbers and no variables. If it's just a number and there's just a number on the other side, well then for sure you can simplify that thing by adding 2 first, not second. Okay, now multiply by y.
So then you have 6y minus 1 is equal to 5y.
And to me this is easier. And now move the 5y over, move the 1 over. There is the solution to that.
Yeah.
Let's check that solution. 5 minus 2 equals 3.
Yeah.
Again, I can't even imagine. I can think of a different way of writing it. Let's just do it. We don't have to necessarily go through the solution. When there's an obvious best way to do it, then I'm not really all that interested in these other ways.
Yeah.
But just so you know, that can be split up into two fractions. 6y over y minus 1 over y equals 5. And that becomes 6 minus 1 over y equals 5. Now if I move everything, if I move the 5 to the left and move the 1 over y to the right, I get that. And now y equals 1. Same solution, done slightly different way. It is important in math to understand that you can break that up into two fractions, and that, what is this equal to over here on the right? Can you do anything with that?
A is equal to...
No, what I'm trying to get at is I can split this up into two fractions only because there's a single term in the denominator.
Yeah.
I cannot split that up. That is not a over b plus a over c. That's not equal to that. In other words, you cannot do it when you have two terms in the denominator. And that's the only thing I like pointing out to people.
Mm-hmm.
You can do it with one term, but not with two. All right, real quick before we do this other relatively easy problem down here to make sure you can handle absolute values. So when I say that the absolute value of something is equal to a number, it always means two things. What are they?
It's a plus and a minus.
Now tell me the two equations.
Oh, so then it's like 2x plus 1 is equal to 5 and 2x minus 1 is equal to 5.
And there's an or between them. And you never change what's inside the absolute value. The only thing you change is the other side.
Oh.
So you're never going to say 2x minus 1, ever. Whenever you have absolute value stuff with complicated stuff in between, never change that. It's either equal to 5 or it's equal to minus 5. Now you solve each one of those. You get x equal 2 in this case. And over here, you get x equal minus 3. So you almost always get two different values when you're solving an absolute value equation.
Mm-hmm.
And you'll notice that each one of them work. If I put in 2, I get absolute value of 5 equals 5. If I put in 3, I get absolute value of negative 5 equals 5, which is a true statement.
Yeah.
And that's the only way I know how to do those also. And I mean that. I don't know of a second method even. Okay, let's go down and look at this one. Doing it algebraically, what are you going to use? What are the two methods that they teach you? So far we haven't used them, but yeah, substitution and what else?
Elimination.
Okay, which one are we going to use here?
Substitution, just substitute 3x plus 2 in for y.
Yeah, I always use substitution when one of the equations is fully solved for one variable. That to me seems to be the easiest way to do all of these. If you have both of them in standard format, then I always use elimination.
Yeah.
Because all I've done is substituted 3x plus 2 for y. And now let's finish solving that because it's interesting. Go ahead.
Then it's 6x, or yeah, 6x minus 6x minus 4 is equal to negative 4.
Keep going.
So then 6x is cancel.
Leaving 0 behind.
Yeah. So then -4 is equal to -4.
What does that mean?
That means that they're like parallel or like the same.
It means that this is true regardless of what x is.
Yeah, it's just.
And you're right. It means they are not parallel, they're the same.
Yeah, they're the same.
There's a difference. If you have two lines that are parallel, there is no solution because they never cross. But if I have two lines and one of them is merely on top of the other one, then there are an infinite number of solutions. In other words, both of these are true, and let's just examine why that's true for a moment. If I solve the first equation for y, here's what I get. Minus 2y equals minus 6x minus 4. And now if I divide everything by minus 2, I get y equals positive 3x plus 2. That's the same equation as the second one. All they did was give us two equations that were the same. And whenever you have two equations that are the same with two variables, you always have an infinite number of solutions. It's like having one equation and two variables. If I give you x plus y equals 10, there are an infinite number of solutions to that.
Yeah.
X could be 1, y could be 9, x could be 2, y could be 8, x could be minus 5, y could be plus 15. There are literally an infinite number of solutions. Now, if at the same time I said x plus y equals 9, well, now there are no solutions. It's impossible for x plus y to be equal to 10 at the same time that it's equal to 9. Can't happen. Yeah. There are no two values that work. Well, the one they gave us, when you try to solve it and you get a number equals another number, as long as it's the same number, that means it's valid for all x. And if you get something like minus 4 equals 2, then it's valid for no x. So these are always no solution. A number equals another number is always infinite number of solutions.
Yeah.
But the biggest thing to remember is infinite number of solutions come when you really only have one equation. You really don't have two equations. They've given you two equations, but one is just a multiple of the other. So it's not different. And that's the key. You cannot add a second equation that's not different and hope to come up with a solution. You have to end up with two independent equations, not two that are dependent on one another. All right. Are we out of problems, Blake?
I emailed you a couple others.
Okay. We've still got 10 minutes. Let's take a look at them.
Yeah.
Oh, that's right. I forgot. I only downloaded the first page. With our 10 minutes, let's go in order here. I got a feeling some of these might have to do with that graph. Is that true?
Yeah.
Is this 2 pages or 1 page?
That's all like one question. Like the graph and then the A, B, and C. Or 5/129.
What I want to do is this. How do I download that? Right over here. I think I got this figured out. Correct?
Yeah.
Kinda, at least.
Yeah. So then Yeah. Then the 5, 129, A, B, and C is the graph right above
Okay.
it.
And what about E above?
Oh, that was just of a different question, but that one, I got that one.
You're good with that one? Okay.
Yeah, put on logs and
So
exponents.
use the graph at right, and I assume it means the multiple choice of graphs.
No, it's just the one like above it, even though it's not at the right.
Oh, so 5129 is talking about this graph up here?
Yeah.
Oh, okay. So use the graph at right, state the domain and range of the graph. Is it a function? Well, what's the domain?
I can't really read it from here.
Well, let me blow it up. In other words, we can answer this one without that other page.
Yeah.
Okay. What's the domain?
Domain is in on the like left side. It's a bracket, and then -4,
Good.
and then parentheses on the other side because it's an open circle.
Comma.
Or yeah, comma, and then is that a negative?
Whatever that number is.
Yeah.
That's 3.
Yeah, so then it's 3 and then a parentheses because it's an open dot.
And that's it. That's the only
Yeah.
domain. These don't have arrows on them. If they had arrows, they would go all the way to infinity in both directions. But since they have a closed dot and an open dot, the only part of the domain is between those dots. What's the range?
And then it's brackets on both sides. And then that's it. Okay, and then it's -5, 5.
-5, comma 5.
Yeah.
Okay. Use the graph at the right. Now, which one are they referring? Or that was it? Yeah, okay. Is that graph a function?
Yeah.
Passes the vertical line test.
Yeah.
Is it a one-to-one function?
No, yeah.
No. It does not pass the horizontal line test. To be a one-to-one function has to pass both. And the advantage of being a one-to-one function is you can talk about its inverse. This function that we're looking at right here, I can't take the inverse of that, because if I took the inverse of it, it wouldn't be a function. In other words, if this one doesn't pass the horizontal line test, then its inverse isn't going to pass the vertical line test. Okay. All right. So now, question B, is it still referring to this graph up here?
Yeah.
Okay. Let me do this then. Ooh. Didn't like that. How the heck do I get my, I want to blow it up. I don't have anything to expand it with. Okay, I'll do it without expanding it. Hopefully you'll see it. It's not that hard to really talk about inverse functions graphically. Every inverse function, no matter whether you're in calculus or algebra or logs or trig, every inverse function is a reflection about that line whose equation is what? Y. Okay. So we're going to take this and reflect it about that line, and that's going to be its inverse.
Yeah, like what our teacher taught us to do, like with these questions where it only gives you points, is like.
There you go. Yep.
Then the x's or the y's, and then the y's are the x's.
Exactly. Exactly. And that is an excellent way to do it. So at this point here, let me just put it in blue. Actually, another way to do it is to know that it's exactly that distance all the way to there. And if that is minus 4, 2, then this is 2 comma minus 4. And do that for all 4 points. But that's what you're doing when you reflect that point across that line, is you are switching the x and the y coordinates. Same thing with that one. In other words, figure out what that distance is, take it perpendicularly, take it to an equivalent distance, put its coordinates on it, do that for all 4 points, and then draw the curve, connecting the 4 dots.
Yeah.
And that's the best way to do it. And what you will discover is that you will not have a function.
Yeah.
It will be, it will look something, I'm not good artistically with doing this in my head. I can't think of right off what that's going to look like, but I suspect it'll look something like this. In other words, it will not any longer pass the vertical line test.
Yeah.
Because it'll have something like that. I don't know. Like I said, I'm not real good at doing graphical inverse functions by hand. I can do them mathematically, but it's real hard for me to do them visually.
Yeah.
Okay. So, state the domain and range of the inverse. Well, I think you'll be able to do that okay.
Wouldn't the domain and range just, like for domain, because there's -4 and 3 in the first one, it'd be 3, -4?
Yeah.
Yeah, and then it'd be flipped the range.
The domain and range of an inverse are always the switched of the domain and range of the function. Whatever the domain of the function is, that's the range of the inverse. Whatever the range of the function is, that's the domain of the inverse. Okay. Let me see if I can take a look at this one. Do we know? Oh, yeah. Write possible equations for each graph below. Are there just 3 of them?
Yeah.
Okay. Let's take the easiest one. We got 5 minutes.
Yeah.
To do all 5 of these, or all 3 of these.
So B is definitely the easiest one.
That's linear, right? So try to put it into this format.
So y2 minus y1 over x2 minus x1.
This is, yeah, you know what B is right away, right? Oh, no, actually you don't. B is right there.
Yeah.
Okay, so let's figure out the slope.
It's kind of tough because I can't like read the coordinates.
I'll give them to you.
Okay.
Okay, so let's start with y minus y1 equals m times x minus x1. In other words, we're not going to use slope-intercept format because we don't know what the intercept is. But what we do have is 2 points, which will allow us to figure out a slope, and then we can use either point to come up with the rest of the equation. So that is -3 minus 7, and that is 3 comma minus 3. So tell me what slope is.
So then you would put, like if you just plug it into the equation.
Y2 minus y1 all over x2 minus x1. That gives you slope. Rise over run. What is that? What's y2 minus y1?
-7 minus, or so -7 plus 3 over.
So that's 4, -4.
over -3 minus 3.
Which is -6. So that gives me
Negative.
a slope of 2/3.
Yeah.
Correct?
Mm-hmm.
Okay, now pick the easiest point to plug in up here into this is the point slope format.
Yeah. So then I'll just do 3, -3.
Okay.
So then it's -3 is equal to 2/3 times.
Plug it into that formula. It's y minus y1. That's y1 right there. That's x.
Oh. Yeah, so
That's the
y
only point we're using. We're not using that point anymore. We already got our slope.
y plus 3 is equal to m times.
What's that?
2/3. So y plus 3 is equal to 2/3 x minus 3.
Right. And that's actually the final answer. You do not need to simplify that. When you get into calculus, this is far more valuable than slope-intercept. So this is the way you leave answers, is in point-slope format. And that's the proper equation for that line, especially with the information they gave us. They didn't really give us much choice as to whether you use point slope or slope intercept, because we can't figure out what that point is, at least not easily. In fact, I'm not sure we can do it not easily even. But using point slope, it's easy to do. Now, I know it's 7. I'll let you go. Let me just suggest some possible equations for this. That looks like exponential.
Yeah.
But it looks like exponential decay.
Yeah.
So maybe 1/3 to the x. Only when x is 0, y has to be 3. So I'll stick a 3 there. And now that certainly satisfies that point. And it's an exponential function that is decaying. In other words, it's approaching the x-axis, but it will never get there. So that's a possible answer. I could also have put any fraction I wanted in here. It didn't have to be 1/3. Could have been 1/2, could have been 1/4, anything. As long as it's less than 1. If it's less than 1, then it will decay. This is a parabola. That is going to have this kind of a format. Only it's a parabola that's been shifted 1 unit to the left and down by 6. So it might look like this instead. There's a parabola that opens up, shifted 1 unit left, shifted down by 6.
Yeah.
So the biggest thing to recognize is when you look at these, you see that's linear, that's quadratic, that's exponential.
Yeah.
Blake, good luck on your test.
Thank you.
Merry Christmas, Happy New Year, and hope to work with you next semester. You taking trig next semester?
Yeah.
I love trig. Trig's a lot of memorization, but it's fun. Okay. Have a good break. Bye-bye.
You too.